In this video, I'm going to be introducing a new series that I'll be working on that's on computer organization and architecture. And really, the main motivation for this series is that with sort of the two main core ideas that I like to talk about, that being assembly programming and operating systems, I've noticed that there's a gap between these two topics that I haven't really discussed at all. And that gap is really represented by this idea of organization and architecture. So basically, the idea is like assembly programming teaches you really how to program an interface with your CPU directly, right? You can run instructions that are going to execute on the CPU, lets you load data into registers, actually do operations on those registers, that sort of idea, right? With operating systems, we're having to work with the whole sort of stack. We have our CPU, we have our memory, right? And then we have all of our different I/O devices, and we have to be able to write the software that allows these things to interact with each other effectively. And basically, the main idea here is that, well, we know how to work with the CPU, but we don't necessarily know how to work with these different memory pieces. And as we get into concepts like paging and memory management, it becomes really, really hard to explain it without a really good understanding of really why we're doing these different things, right? Why do we care about paging? Why are we doing memory management, right? So understanding these pieces is really the core of what a typical course on computer organization architecture would cover. So generally, the idea is that we're going to work from really the bottom up. We're going to take a look at things like data representations in binary. We're then going to go into things like digital logic. We're going to take a look at the actual circuitry involved. And then we're going to build our way up to assembly programming. And then we're going to talk about hardware and the different abstractions that we can do with that hardware and take a look at how that fits into interfacing between the CPU, main memory, and I/O devices, right? The typical like von Neumann type architecture. This main goal is going to allow me to both explain assembly in a lot more detail, as well as operating systems in a lot more detail. Because I found that with my operating systems explanations, they sort of fall flat because they don't talk about a lot of these core concepts of how things are really interacting with each other. So my hope is that by showing these concepts in a lot more detail, I can actually, flesh out these operating system videos a lot more and actually give you a much better explanation of the concepts that are actually related to operating systems. So I want to take this series really beyond just like, showing code for operating systems and actually explain to you how things are working. And in order to do that, we have to do a bit of organization and architecture. So that's what this main series is going to be on. All these series videos will be uploaded to YouTube as usual, so they'll be freely available for you to be able to view. I'm going to try to upload them on a relatively consistent basis, but I'll just keep updated as I continue to update and upload, and that's primarily what we're going to be working with. So we're going to be starting by talking about the general idea of computer systems, the hardware that's involved, and then we're going to start moving through this general stack of talking about data representations in binary, going into a lot more detail than like the basics of binary that I've talked about so far. And then we'll talk about digital logic, we'll talk about, assembler architecture, and then finally get into things like hardware, paging, memory management, these types of ideas. So I'm really excited for this. I think that it will be a really interesting course if you're interested in low level and general programming like this. So thanks so much for watching, and I'll see you in the next video.